Alright, this is a quick demo of the motor control demo board for the CSU IEEE Design Contest workshops. When you first turn on the board, it'll show you a message, unplug USB. You don't want to test your motors while you're still using USB power. Right now I'm using batteries, but you can also use a wall wart. So the first motor we have on here is a servo motor. Servo motors typically can be positioned between 0 and 180 degrees. Some of them only go to 90 degrees. Depends on the specific motor you get. And the nice thing about a servo motor is they're very easy to control their position, since they have a motor controller built in and you're just sending it data and power. Next motor we have is a DC motor. These motors are cheap and they spin very fast, but they're harder to use than some of these other types of motors. And you need some sort of, if you have a position sensitive system, you'll need some sort of position sensor. The next motor we have here is a small stepper motor, and these two buttons control the direction, and the last two buttons will control the speed. If you hold it down for a while, you can make it step faster. And the stepper motor is driven by this Darlington array chip. Actually, both the DC motor and the stepper motor, and also there's an output for a solenoid. I don't have a solenoid on me at the moment, but you can control it very similar to a DC motor. So this Darlington array is an NPN array, so it can only pull down. So in order to hook up to this bipolar motor, we have four like half-watt transistors, half-watt resistors here that are connected to power, and so they will pull up. And so when all of these Darlingtons are off, all of these the four wires will be at 5 volts, and then you sequence the control of the Darlingtons to pull down, because the Darlington will pull down harder than the resistor can pull up. And if we look at the steps on the oscilloscope, basically the important thing to get is there's 4 states and they shift in phase as you go along. So that's how a stepper motor is controlled. And this is actually, if you look closely, you can tell it's half steps, which is gives you double the resolution at the cost of some torque during the half steps. So this motor has 20 steps per revolution. Bigger motors usually have more steps. Like 200 steps per revolution is a common number. So that's the demo of the board, and see the write-up for schematics and instructions on how exactly to hook this up.